Oh boy. Another day. Another day, another day. Would you look at that? Sheesh. Yeah, pick out some music here. All right, y'all. What up? So YouTube let's I got creator music here. So I've got a lot of songs actually have revenue sharing, which is pretty cool. So I don't get hit with copyright strikes. I can play some songs in the background, which is pretty nice, rather than just kind of aimless beats that we've heard over and over again. So I'm down with that. All right, you guys, what's going on? I hope you're having a good day today. Ooh, dropping frames. Ooh, my bad. This is my desktop. Tired of looking for it. Okay, cool. So we're back in chapter 7 today. Gonna be going back through our notes here and getting an update on the sections that we didn't take notes for. To get a second pass to help us out with our learning, reinforcement, and also get some more info, right? My mouse is running out of juice here though, so I might need to plug it in soon. Okay, so oh, thank you so much for the follow, Francis. Appreciate you so much. Welcome. Okay, floating types. So let's go over and talk about some of these guys, right? Um, Okay, so integer types are suitable for all applications. Sometimes we need to store numbers and digits after the decimal point, right? So this is where we get floating points. C provides 3 floating point types. So we'll go and do 3 floating point types. One is just the float type, which is single precision floating point. Right, we'll copy this down. This is going to be double, and this is double precision floating point. And then down one more time here, we have long double, which is for extended precision floating point. Okay, so then we go over some more detail here. The float is suitable for when the amount of precision isn't critical. So we'll say suitable for when the amount of precision isn't critical, calculating temperatures, use one decimal, for example. We'll take that right from the book. Cool. Double provides greater precision, enough for most programs. Kind of a, not a very great one, but it's whatever. Than float. Enough for most programs. And long double, which supplies the ultimate precision, is rarely used. Provides the maximum or ultimate precision, I guess. I don't know if it is the maximum. And is rarely used. Let me go to my nice friends. Okay, cool. Most modern computers follow the specifications IEE standard, also known as this. Okay, so here we go. So we have this, the IEEE floating, oh wait, hold on, so IEEE floating point standard. So this is a IEE standard 745 developed by the Institute of Electrical Engineering, Electronic Engineers, provides 2 primary formats for floating point numbers. Okay, so a general definition of this is most modern computers follow specifications in this. So specifications followed by computers. Followed by computers regarding floating point values. So this IEEE standard 754, developed in the Institute of Electrical Engineering and Electronics Engineers, Electrical and Electronics Engineers, provides 2 primary formats for floating point numbers: single precision for 32 bits and double precision for 64 bits. So we'll do, let's make this IEE standard developed by the Institute of Electrical and Electronics Engineers provides 2 primary formats for floating point numbers. Number 1, single precision for 32 bits, right? And 2, double precision, 64 bits. Numbers are stored in a form of scientific notation, with each number having 3 parts: a sign, so a form of scientific notation. Each bit having a sign, 3 parts: a sign, exponent, and a fraction. A sign, positive, negative, either 1 or 0, indicating positive or negative, right? the exponent value, which is the value of the base, and then the fractional part. The number of bits reserved for the exponent determines how large or small the number can be. Well, the number of bits in the fraction determines the precision. Okay, right? Take this. Numbers are stored in a form of scientific notation with each number having three parts: a sign, an exponent, and a fraction, right? The exponent the number of the bits reserved for the exponents determine how large or small, right? The number of bits reserved for determines how large or small numbers can be. The fraction determines the precision. Okay, in single precision format, the exponent is 8 bits long. Okay, what we're going to do is take this part and bring it up here. Right here. Okay, so in single precision format, the exponent is 8 bits long, right? 1 byte. While fraction occupies 23 bits. Right, so just shy of 4 bytes. Because that last byte, right? That last byte is reserved for the sign, the single value of the sign, thus making the total value. Oh, did I say 5? Sorry. Am I done? 3. Right. Let me respond to my lady friend. All right. Okay, cool. Bro, it's tripping. Okay. So, right, it's a total of 4 bytes. We have 3 in the fraction and the sign, and then 1 in the exponent. Total 32 bits, which is the which is single precision, right? Yeah. And then the sign is 1 bit. That makes sense. So yeah, this is why we go over it a second time. It helps just pass through it again. Doesn't have to be fast. You can just kind of skim it the second time. As a result, the single precision number has a maximum value of approximately this, with a precision of about 6 decimal digits. Okay, so we'll say max value is equal to 3.40 times 10 to the power of 38 with about 6 decimal digits. Cool. The IE standard also describes two other formats, single extended precision and double extended precision. The standard doesn't specify the number of bits in these formats, although it requires that the single extended type occupy at least 43 bits and double extended type at least 79 bits. For more information about the IE standard floating point arithmetic in general, see what this right here. So it didn't talk about double here though, it just talked about the single precision one. The number of bits reserved in exponents, how large can numbers be? Oh, maybe this is just... What is this? Hey, bro from Beyond, how's it going? Bro, gotta stop spamming stuff if it's like not even related to the stream, Francis. I'm gonna have to time you out. I don't really want it on my video for long playback. I can't even understand a word you're saying. Okay. Okay, the IE standard also describes two other formats. So there's two other formats, which is single extended precision, which is at least 43 bits, and 4 double extended precision. Oh, it's so cold. Can't type. Double extended precision, which is at least 79 bits. Okay. Table 7.4 shows the characteristics of the floating point numbers when implemented in the IEE standard. Table shows the smallest positive normalized values. Subnormal numbers can be smaller. The long double type isn't shown in the table since its length varies from one machine to another, with 80 bits and 128 bits in most common sizes. Okay, so this... We'll throw this guy into here. On computers that don't allow the IEEE standard, this won't be valid. In fact, on some machines, float may have the same set of values as double, or double may have the same values as long double. Macros that define the characters can be found in the header file. We'll say, we'll go like this and say float.h provides macros on float bit length characteristics. Okay. In C99, floating types are divided into two categories: float, double, and long double types. The float, long double, and long double types fall into one category called real floating point types. Okay, so we'll say C99 two right, in C99 two floating types. One is C99 is two floating types category. Number one is real floating types. Which consist of the float, double, and long double. Okay. And then we have two floating types also include the complex types. Complex types, which consist of float underscore is that a space? I don't think that's a space. I think it's a S underscore in between them. Okay, the same thing, so we're going to add this complex value to them. Float underscore complex. Double underscore complex, long double underscore complex. I can't tell if that's a space or not. I don't think so. Which are new in C99. Floating constants. Floating constants can be written in a variety of ways. The following constants, for example, are all valid ways of writing this number. Okay, so let's just do here. Floating constants. And so an example would be 57.0, 57, or 57, or 57.0 E0, or 57 E0, or 5.7 E1, or 5.7 E plus 1, or 0.57 E2, or 570 point E to the negative 1. Floating constants can be written in a variety of ways. The following constants: a floating constant must contain a decimal point and or an exponent. The exponent truncates the power of 10 by which the number is to be scaled. If an exponent is present, it must be preceded by the letter E or E, and an optional sign may appear after. Okay, so we'll do a definition here. Must contain a decimal point and or exponent. The exponent indicates the power of 10 by which the number is to be scaled. If the exponent is present, it must be preceded by the letter capital E or E. An optional plus or minus sign may appear after the E. There we go. Okay, cool. By default, floating constants are stored as double precision numbers. In other words, when C compiler finds the constant 5.7 program and ranges the number. So these are automatic stored as double precision numbers in memory for easy conversion to float if need. On occasion, it may be necessary to force compiler to store a floating point number in float or long double float to indicate only single precision float. Okay, so you can okay, so hey Ray, how's it going, dude? Okay. um Force float or long double format to force a long double float to force long float format append letter capital F or lowercase f at the end of the constant. Append F or okay, and then for this one you're going to append the letter capital L or lowercase l. C9 has a provision for writing floating constants in hexadecimal, such as constant start begins with 0x or 0x. So we'll say C99 hexadecimals begin with 0x or 0x. Okay. Nice. Reading and writing floating point numbers. As we discussed, the conversion specifications %E, F, and G are used for reading and writing single precision floating point numbers. Values of double and long double require slightly different conversions. When reading and writing long double letters, right, you put the letter E in front of the E, F, or G. Sorry, you put the letter L. Okay, so we'll say reading and writing floating point. So for remember, So percent E percent F and percent G are used for for single precision numbers, floating point numbers. Right. We discussed that back in, I believe it was chapter 6. Let's make sure we can make a reference here. No. Maybe it was back in 3. Yes, chapter 3. Okay, so for long double, right, what are we going to do? For long doubles, we're going to add a prefix with an L. Prefix the with use lowercase l only in scanf format string, not a printf string. In its printf format string, the E, F, and G conversions can be used to write either a float or double values. C99 legalizes this use and calls to printf, although L has no effect. Oh, this is for when reading. So for reading, and make sure I specify that, long double prefix with the L. And so this will be like in, scanf. Because you need to tell it like how much space and memory to reserve up front. It's kind of like easier for the computer to kind of say, oh, we can just kind of use a catch-all to print it because we can do some under the table conversions or whatever if we need to. It doesn't really, but to save it, we have to allocate enough space. So we really need to know the difference between whether it's a long double versus a double or whatnot versus just a float when reading the data in, right? That's important. And so then I'm my bad. This is for double. And then for, oh, this is going to be confusing. Long double. Prefix with capital L. Okay. So we'll say when printing floating point numbers, oh, so when you printf, you need to specify a long float when you printf, a long float. Oh, that's confusing. Wait. So this is the variable. This is the type of data point we're reading in. So this variable LD, but this is a long double. So this is of long double type, right? Now, long double is an extended floating point, provides ultimate precision, is rarely used. Okay, but we also have a long, no, it's a long int. Okay, that's why I get confused, I'm sorry. So for integers, you have short, int, long, long int. For floats, you have float, double, and long double. Okay. Now, this makes a long double type of float with a variable LD. I don't really like how they do this, but whatever. We're going to scanf, so we're going to read in from the standard in, right? Is that what it is? From the terminal. We're going to read in a long float value. A long double float value. Okay, right? And then we're going to print out, and we're going to save that into the long double. I wish we could just use the D, like a D here. It'd be so much easier. I think that's what's throwing me off. Is I don't like how they use the same variable name as like whatever. It's kind of annoying. Oh, we got a lot of people in here. What's up, Ray? What's up, Ahmed? How's it going? I'm new to C. How's it going? What's up, Simon? Yeah, me too. We're gonna get some CU practice here. Yeah, the book. It's you can find it online. You search it up at C Programming: A Modern Approach. Or I got a lot of stuff in my Discord, completely for free. Okay. So. Yeah, these types are gonna need to get like some used to. Not having used to having so many types, used to the luxuries of Python, doing it all for you and breaking it down in just a couple of things you have to remember, not a bunch of things you have to remember for different sizes, right? And then those sizes can change depending on which type of implementation the compiler or your computer, right, or whatever reads. Say is integer values in memory as or whatever. So it's like, right. Okay. This is getting up there here. Okay, we got to keep going. All right, let's we got to keep going. Okay, 7.3 here. We're just going back through our reading from the other day and updating our notes here. The only remaining basic type is char. The character type at this type of value. Char can vary from one computer to another because different machines may have different underlying character sets. Okay, so you have char type, which can vary from one computer to another because different type of character sets. The values can vary from one computer to another. So character sets. Today's most popular character set is ASCII, American Standard Code for Information Interchange. So ASCII, American Standard Code for Information Interchange, right? A 7-bit code capable of representing 128 characters. So in ASCII, digits 0 to 9 represented by the codes this new. Okay, here. Okay, so right, these are 7-bit codes, right? So each of these is 7 bits. 1, 2, 3, 4, 5, 6, 7. And these codes correspond to just various numbers, right? It really kind of does break down if you've ever gotten. Give me 1 second. I don't know if you guys have ever read this book. I've been working my way through it little by little off stream. But it really does kind of come and break down back in the day to, Morse code, little things representing, communicating through yeah, cool. All right, let's keep pushing. ASCII is often extended to a 256 character code known as Latin 1. So this is often extended. So we'll say Latin is an extension to 256 characters necessary for Western European and many African. Whoa, what happened there? European. A variable of type char can be represented as a single character. So char can be like any of this. Right, so can be assigned any single character. Actually, I'm going to delete this. I'm going to copy in that note. Hey, what's going on, Slope? I don't know if it's bad practice or whatever, but I never use these long types. I just use int64_t. The one that's kind of universally, we learned about that last time in the reading. We're going to get to it later on in the reading here for our note refresh. Oh, hey, thanks for the sub. Appreciate you so much. And you, Cleo Cat, thank you so much for the, I like that name, Cleo Cat. Sareth, you too. Thanks so much for the sub. You're awesome. Yeah, we learned about how you have these underscore t variables, which the compiler will kind of automatically insert. I believe, right? It'll automatically insert the necessary according to the header files used in the compiler, right? It's like predefined values that are that no, not predefined, but there's like up to the interpretation of whatever the machine may use. If it's like can be loosely, I don't know. We're gonna get more information on it later here. A couple more pages. Okay, well, operations on characters. Working with characters in C is simple. Treats characters as small integers. After all, characters are encoded in binaries. It doesn't make much imagination to view these binary codes as integers. Got the hiccups. In ASCII, for example, character codes range from this to this, which we can think of as the integers 0 to 127. The A character has a value of 97, whereas the capital A has value 65. 0 has a value of 48, and space has a value of 32. Connection between these characters in C and integers is strong. So strong that the character actually have type int rather than type char type. An interesting fact, but not really one that often matters to us. When characters appear in computation, C simply uses the integer value, considers the example. Oh, so these are just the bit codes representing these characters specifically, but their values of total range from 0, 0, 0, 0, 0, 0 to 1, 1, 1, 1, 1. Okay, got you. So we'll just make a note here and say we'll say character codes range from 1, 2, 3, 4, 5, 6, 7 to 1, 2, 3, 4, 5, 6, 7. We can think of these as integers ranging from 0 to 127. We'll say, quote, A, we don't need to do that one. Okay, so then we go here, copy this image, here. Characters actually have a type of int rather than char type. They can be compared like the numbers can. Char is actually just int. It's just an int wrapper, just to make it more user-friendly. It's actually just an int, so we can compare using logical operators like less than, greater than, less than or equal to, greater than or equal to. My headphones are dying. Elite drip. What the heck? I don't got no elite drip here. Just got a hoodie on. Two things I'm like walking down the red carpet here. Okay, so then we'll take this example here. Throw it in here. Remember, you guys can, these notes are in my GitHub down below. So if you want access to them, they're all for free. In my GitHub, I push them up after each chapter. I do stuff. Oh boy. Sorry, Wen. Someone's gonna have to translate that for us. Tim, you got us on deck with a translation here? Sorry, my boy. It's been a while since Spanish from high school. Can lead to various programming errors that won't be caught by the compiler. Meaning expression like this. This can also have reportability since our programs can be based on assumptions. Okay. Signed and unsigned characters. C allows characters to be used as integers. It shouldn't be surprising that char type can be like integers exist both in signed and unsigned versions, since characters normally have values between signed characters have values between negative 128 and 127, while signed characters have value of 0 to 255. So signed. So since we'll just take this here. Come on, boom. Okay, then we'll go here and do signed characters. Normally have values between negative 128 and negative 127. Unsigned characters between 0 and 255. While others treated as unsigned, okay, yeah. The C standard doesn't specify whether ordinary char is a signed or unsigned type. Some compilers treat it as signed type, while others treat it as the unsigned type. Some even allow the programmer to select via a compiler option. Most of the time, we don't really care whether it's signed or unsigned. Once in a while, though, we do, especially if we're using a character variable to store a small integer. For this reason, C allows the use of the word signed and unsigned to modify char. Don't assume that char is either signed or unsigned by default. If it matters, use signed char or unsigned by char instead of just char. In light of the close relationship between the characters and integers, C89 uses the term integral types. Okay, so we'll say C89 uses the term integral types to refer to both the integer types and the character types. Enumerated types are also integral types. But C99 doesn't use the term integral types. Instead, it expands the meaning of integer types to include the character types and the enumerated types. C99's underscore bool type is considered to be an unsigned integer type. So who's got a reason why we would use signed versus unsigned characters? They didn't really give us like that great of an example here. Vintage drip. This is not vintage drip. This is like from like 2019. This is not even, yeah, this is like from like 2019. This is like this is a store from it's a local brand in Portland where I grew up. I was born and raised in Portland, Oregon. It's a local brand called Portland Gear that was created by a guy. The owner and creator and CEO of it he went to the same high school as me. I graduated from the same high school as me. Many years before me though. He's quite a bit older, probably 8 to 10 years older than me. But yeah, I did some work for him one summer or one winter break in college, and I got some stuff. uh, Casual vintage future and like fancy trips not considered try hard. You guys are always gassing me up for just nothing. If you guys want to see like vintage drip, I'll have to actually bust out some of the band tees and stuff that we have, and like my girlfriend's got all the vintage stuff, not me. I just have like the same stuff over and over again. Um, Wen says, this is the translation. You're learning Python and C at the same time. Answer in chat because I don't know English. So I'm trying to translate with Google Translate. I'm also learning Python, but it's been very difficult for me. I went to college and programming is a struggle for me because I learned something and then forgot it hours later. Yeah, it's honestly, don't feel bad. Like I do that too. It's very common. It's a lot of information to absorb. I mean, think about like even going to a simple like lecture where you just learned about like one topic or for like 45 minutes or whatever. And even after that, walking out of there, you're like a day later, you don't remember anything, right? It's the same type of thing. And so that's why I think that it really helps for uh, like second passes like we're doing now. We went through and read. We took some notes on some few things with the time that we had, but then we committed to ourselves to come back through and just do a skim. We're not going through and reading word for word. We're kind of skimming and picking out the most important things that we think, and we're going to take fill in our notes. Now, you probably should do a better job than I did and not do completely blank sections. Probably like add in some bullets to go back through and hit. Would be the best way to do it, right? That's probably what I'll do going forward. I definitely don't want to do blanks like reading. I probably should do like some bullets to come back and fill in like I'm doing now. Um, but come back through and fill it in, and then also coming back through at the end of the chapter and doing the programming questions and the exercises and stuff. But then even it's kind of funny, like I'll even get more exposure to the topic because I go back through and I have to edit the videos for re-uploading to the channel. So that was also like my kill two birds with one stone, my little like white guy unk saying phrase, Tim and Slow. Um, you can really, I kind of have this perk or I don't know what it is for killing two birds with one stone here, where I have to go back through and edit the video, and so I'm literally just listening to it again, and then I'm just chopping it, and so I get like a lot of exposure to the same thing. Unsigned char is usually used to represent a raw byte of data. So this would be unsigned, meaning guaranteed to be positive, right? So either 0 to 255 for a character. And so if we want it to represent a, okay, because you can't have negative memory, right? You can't have signed memory. It can be signed, right? It can have a 1 in it for one of the signed bit, but the memory, you can't have like a negative memory address like in that sense, right? You would want to, is that what you're representing? A raw byte of data. This is more important during 30-bit 2 time. Okay. But back in the day, you could sacrifice a number being 2 to the power of 32 big versus 2 to the power of 31 big. But when you get negative numbers, but you get negative numbers. Also, unsigned integers don't usually have UB for integer flow. Overflow. What is, sorry, you're going to have to break down some of these acronyms. UB. They just wrap around. Don't have a... Interesting. We're getting the facts here, boys. Hey, Mateus, welcome in, dude. Ray, Tim, Cloudosity, welcome. Everybody, welcome in. Okay, we're almost through these. Let's keep filling in. What are these? What are these? Undefined behavior. Okay, so also unsigned integers don't have undefined behavior for integer overflow. They just wrap around. Okay, so that if you now, we talked about integer overflow, didn't we? Yes. The result of arithmetic operations becoming too large for the initial variable type. Overflow of signed integers causes undefined behavior. Overflow of unsigned integers yeah, this is what we talked about before, right? Right here. The overflow of unsigned integers will just wrap around to that next side, basically, right? To the maximum and then the remainder of that operation. Look at us taking good notes here. Here we go. Oh, should I move chat? My bad, you guys. Come on, Mike. You gotta be a better streamer than this. Let's move chat like here. That's a good place for it. That's like a perfect place for it, actually. Okay. Arithmetic types. The integer types and floating point types are collectively known as arithmetic types. Integer types and floating types. Sorry. The integer types and floating types are collectively known as arithmetic types. Here's a summary of arithmetic types in C89, divided into categories and subcategories. So, these together are collectively known as this. So it's just like an umbrella term for all of them together. Integral types are char, signed integer types, signed char, shortened, and unsigned integer types. So both chars and ints combined. With enumerated types. What is enumerated types? Did we learn about this? The data type consisting of a set of named values called elements, members, or enumerated, consisting of it's just like a list, an array, a fixed set of related constants. What is this definition? Enumerated type enum or factor in the is a condition name. For example, the 4 suits in a deck are playing cards, have 4 enumerators called the club, diamond, heart, and spade, belong to an enumerated type called the suit. If the variable v is declared having a suit as its data type, one can assign any of those 4 values to it. Although enumerators are usually more... Give me this boy. Give me this boy. Enums let you assign symbolic names to integer constants. Let you assign symbolic names to integer constants. They make code more readable, safer, and easier to maintain. An enum is a user-defined type that consists of a set of name integer constants. Enum for a color. So it's like a structure of integer constants with no like with variables behind the scenes? Is it like a how to declare and use an enum? Assigning custom values. You can set specific numbers like this. Avoid writing enum every time with typedef for a switch state. So you have an enum with two values, either 1 or 0, I'm assuming, for on or off, true or false. You define a custom value for this Boolean, which is a typedef, so you're defining a type. And this type can only have these values. So is this just like simplified object-oriented programming? I don't know. Maybe not. So if status equals to error, good. Status equals to 4, what? So if you say switch for the variable today, and you're going to look for a case of Monday, print start of the week. Okay. Oh, I'm getting tired. Okay, we gotta power through. Power through. We're almost there. Hold on. We're not even close though. We got like 20 more pages of notes. Oh my gosh. This chapter was long. It's like 25 pages. There's so much to learn. It's a lot of information. They say it's a relatively simple language. I wouldn't want to see what some of these more difficult ones. Jesus Christ. C++ might just kick us right in the gonads. The integer types are collectively known as arithmetic types, so... So in C89... C89... summary of arithmetic types in C89. Categories and subcategories. So you have 1, which is integral types, which consist of char, signed types, signed integer types, unsigned integer types, enum types, 2 floating types. And then in C99, oh gosh. Oh. Oh my gosh, where did my copy go? Okay, integral types are chars, signed types both standard, unsigned char, numeric types, floating types, real types. This is both real floating types and complex types. Okay. Escape sequences. A character constant is usually one character enclosed in single quotes, as we've seen in the previous examples. However, there's certain special characters. Okay. Escape sequences. Programs can deal with every character in the unknown character separately. Difference. A special notation that provides a special notation that so that the program can deal with every character in the underlying character set. There are 2 kinds of character escape sequences. So there's one which is character escapes, and there's 2 which is numeric escapes. So character escapes was partial list here. And this one gives the complete set here. So character escapes are these guys. Oh. Oh. Oh, a few. Didn't just dox myself. I was like, uh-oh. Copy image. Oh, my bad. So there we go. And then these represent common ASCII controls that we know of, right? You can escape the backing, right? Cool. Character escapes are handy, but they have a problem. Those characters don't include all the non-printing ASCII characters, just common characters beyond the one. To write a numeric escape for a particular, so numeric escapes can represent any character. So character escapes the list of character escape does include all the non-printing ASCII characters. Numeric escapes can represent any character. To write a numeric escape for a particular character, first look up the character's octal or hexadecimal value, like the one in Appendix E. Oh, God. example, they ask you what escape character or decimal value 27 has a value of 33 in octal and 1B in hex. Either of these codes may be used to write an escape sequence. So these are just what? Octal escape sequence, hectals. Ugh, this sucks. So much notes. Consists of this character followed by an octal number with at most 3 digits. This number must be represented by an unsigned character whose maximum value is number 377 octal. And then there's hexadecimal. Which consists of the \x followed by a hexadecimal number. Although C places no limit on the number of digits in the hexadecimal number must be represented by an unsigned character, hence it can't be exceeded by FF, and characters are 8 bits long. So I'm just going to take this whole paragraph. It's a lot of information, so if you ever want it, it's here. X 1B or 1B. Okay. I'll just do this. I'll keep the whole paragraph then for this guy as well. Okay. Trigraph sequences provide a way to represent these characters, which may not be available on some keyboards. Whatever. I respect your grind. Thanks so much. Terry Davis. Hope I don't crash out like Terry Davis. I'll take his programming all day long. That's funny. If you guys are new here, appreciate it if you guys subscribe and like the stream. Really goes a long way. Just trying my best to show up for you guys every day. Earlier in this section, we wrote how to write if statements. This isn't the best method, although a more portable way to convert is called use toUpper. Okay, we talked about toUpper. So let's talk about toUpper. A function in C's C type. That converts a character value to its corresponding uppercase character value. So if it returns the output, otherwise. Cool. So reading and writing, characters, use %C. reading and writing characters, the percent C conversion specification. Cool. We'll take that all day long. How to... And then alright, and we'll take this example that it gave. Copy. Nice. Scanf doesn't skip white space character of reading a character. As the next unread character is white space, the variable ch in the previous example will contain white space. We'll say scanf does not skip white space for character before reading a character. Recall that a blank scanf string means skip 0 or more white space. Since scanf doesn't normally skip white space, it's easy to detect it at the end of the input line. Check to see. So in this one, we'll skip white space and then read it. But when we're doing numerical values, it will skip white space and just extract out the value. But also, this does skip the value. Put a space into the format string to force skip of white space. Okay. Okay. Keep it up. C has some rough edges, but it's still a great language. Yeah, trying my best here. Thank you, Eclipse. I appreciate the pat on the back. You guys are awesome. It's important. I love you guys. You guys are great. You guys are awesome. I love it, and I love it, and I love it. I love that clip. Okay. It's easy to detect the end of an input line to check to see if the character just read the end of a new line character. For example, the following loop will read and ignore all remaining characters in the current input line. Scanf doesn't normally skip white space. It's easy to detect the end of the input line. Check to see if the character just read is the new line character. Yeah, right. So you can check to see if it's a new line character to see if it goes to the next line. Okay. Okay. Oh, dude, there's so many notes. This chapter is kicking me in the tail. 180 lines so far. Come on, dude. We might have to break this one up again. We have like 15 more pages. Get char. So get char. Put char instead of climb. And then we have put char. Will print writes a single character to the terminal, getChar will, it reads one character, which is returned in order to say this character. Reads one character from the terminal and returns it. Yeah, for real. Right, low. GetChar actually returns an int value rather than the char. Returns an int value rather than the char value. As a result, it's not usual for a value to have type int rather than char if it's to be used to store any character read by getChar, like scanf. GetChar doesn't skip white space characters as it reads. Using getChar and putChar together then scanf saves time when the program is executed. getChar and putChar are faster for two reasons. They are much simpler in design. getChar and putChar usually implement as macros for additional speed. getChar has additional advantages over scanf because it reads the character it gets. getChar lends itself, because it returns the character, it lends itself to various C idioms, including to loops. Okay. Does not skip white space. Okay. So you'll go and continually get the char until you get a new line variable. So we'll say char equals to getChar, putChar of char. Okay, cool. So then you can use them in loops, which is really nice. You can skip loops, go to the end of the line, skip the rest of the line. Be careful if you mix up getChar and scanf in the same program, as a tendency to leave behind characters it is peeked at. So enter an integer, scanf will read it. So the getChar might get a character that was left behind that wasn't included in the scanf, like a space or something. The call of scanf will leave behind, yeah, right. So then you can determine the length of a message here with the program to loop through and increase a counter for how many getChars you call, right? And then you can condense it into a single kind of one-liner here with this while getChar is not equal to the new line character will increase the length. Just do a short loop to print out the length of the string message. Okay. Making some progress here, finally. Hey Moza, how's it going? Can I call you dad? Bro, come on. I'm only like 26. What's up with this dad stuff? So we're like seeing a 26-year-old or like what is up with dude has some gray hairs coming in. Alright. 7.4. The computers tend to be more restrictive than C when it comes to arithmetic. For a computer to perform arithmetic operations, the operands must usually be of the same size. Number of bits to be stored in the same way. Computers must be able to add 16-bit integers directly, but not 16 bits and 32 bits, or 6 32-bit integers and 32-bit floats don't work, right? C, on the other hand, allows for basic types to be mixed in expressions. So some operands of different types so that the hardware will be able to evaluate some expressions. If we add 16-bit short and 32-bit int, for example, the compiler will arrange for the short value to be converted to 32 bits. If we add an int value to float, the compiler will arrange for the int value to be converted to float. This conversion is a little bit more complicated since int and float values are stored in different ways. Because the compiler handles these conversions automatically without the programmer's involvement, they're known as implicit conversions. So implicit conversions. Conversions that the compiler does for you during arithmetic that can be safely, assumed, like converting a 16-bit short by adding a a 16-bit short, come on, type, to and a 32-bit int, the compiler will convert the short to 32 bits. If we add an int and a float, the compiler will arrange for the int to be converted to a float. Right. No. Int plus float equals to float, etc. Because the compiler handles these conversions automatically without the program's involvement, they're known as implicit. C allows for explicit conversions using the cast operator. So we have these explicit conversions. I don't know, like programmed conversions using the cast operator. I'll discuss implicit conversions first, blah, 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 blah. When the operand is arithmetic or logical expressions don't have the same type. So these are implicit conversions. Then we have when the type of expression on the right side of the assignment doesn't match the type on the left. We have when the type of an argument in a function call doesn't match the type of a corresponding parameter. And we have when the type of an expression in a return statement doesn't match the function's return type. So these things C compiler will do automatically for us, probably raising a warning, but will implicitly convert for us in some, well, probably in some statements might raise a warning, probably some it won't. Like in some of these ones they won't, but maybe in like this one it will. If like, oh, it recognizes it's not getting back an int, but it's getting back maybe like a, I don't know, maybe not. Okay, usual arithmetic conversions. Okay, so usual arithmetic conversions are applied to the operands of most binary operators, including arithmetic, relational, and equality operators. For example, let's say that the f variable has a type float and I variable has a type int. The usual arithmetic conversions will be applied to the operands in the expression f plus I because their types aren't the same. Clearly, it's safer to convert I to type float, matching f's type, rather than convert f to type int, matching i's type. An integer can always be converted to a float. The worst going to happen is minor loss of precision. Converting a float point to an integer, on the other hand, would cause a fractional loss of the number. Worse still, we'd get a completely meaningless result if the original number were larger than the possible integer or smaller than the smaller integer. The strategy behind usual arithmetic conversions is to convert the operand to the narrowest type. Okay, so convert the operand to the narrowest type that will safely accommodate both values. Roughly speaking, one type is narrower than the other, which requires fewer bytes to store. Right, I remember that from when we are reading. Right, the type of these operands can often be made to match by converting the operand to the narrower type. This act is known as promotion. So promotion is converting the operand to the narrower type by matching the type of the upper operand. Among the most common promotions are the integral promotions, which convert a character of a short integer to type int, or unsigned int in some cases. Okay. We can divide the rules for performing the usual arithmetic into two cases. So 1, the type of either operand is a floating type. 2, neither operand type is a floating type. So in this first case, we use this type of hierarchy promotion. If one operand is a type of long double, then convert the other. So you'll kind of, if one operand, like you'll cast upwards to the corresponding more dominant type, right? With more bytes. With fewer bytes, the store is more narrow. Yeah. And then with neither operand as a floating point type, you follow this integer hierarchy here. What do I do for a living? Oh, I have a degree in human biology and a minor in chemistry, and I work as a formulation chemist for a biotech company since I graduated college back in 2021, at the beginning of 2022. I have about 4 years of experience doing that, but I would like to, get into software and maybe combining the fields if I have an opportunity, but I don't know, dude, job market's pretty bad, so not looking too hot. Not looking too hot. And you guys got referrals out there, let me know. Okay. I'm good for the word. There's one special case, but it only occurs when long and unsigned int have the same length, 32 bits, let's say. Under these circumstances, if one operand has type long int and the other has type unsigned int. Okay, so neither operand is floating type. First, perform integral promotion on both operands, guaranteeing that neither operand will be a character or short integer. So we need to first make every short or character automatically promote to an int. Then we will use hierarchy to cast these upwards, right? Now, if a longer integer, which can be both signed or unsigned, and unsigned, which is positive integer. Let's say they both have 32 bits of storage space available to record these long numbers, both long int and unsigned int. If the operand has type long int and the other has type unsigned int, both are converted to unsigned long int. Okay. Okay, so then we have usual arithmetic conversions here, like an example. Usual arithmetic conversions don't apply to assignment. Instead, C follows the simple rule that the expression on the right side of the assignment is converted to the type of the variable on the left side, if the variable is at least as wide as the expression. So we'll say why is the expressions? So then we'll take this example here. So implicit conversions in C99, the rules for implicit conversions in C99 are somewhat different from the rules in C89, primarily because C99 has different additional types. Okay, so in C99, for the purpose of defining conversion rank, C99 gives each integer type an integer conversion rank. The C99 rules for performing the usual can be divided into two cases. I hate how it gives us C89 crap. Honestly, that's one annoying part about this book is I really don't care. So this is C89. So then it's C99. these two types. The type of operand is neither floating type, neither operand is a floating type. The first proportion of both operands. If the type of the two operands is now the same, the process ends. Otherwise, use the following rule, stopping at the first one and then applies. If both operands are the same types, both have unsigned types, convert the operand whose type has lesser integer conversion rate to type. Both have convert. This is brutal. This chapter is so long. And then these guys here. Jeez. I followed to the 30th episode. It's in Windows, but still relevant. Sorry, what do you Eclipse? Okay, so casting here. Although C's implicit conversions are convenient, sometimes we need a greater degree of control. We can provide casts. Cast names. Okay, we have this here. Type name specifies which the expression should be converted to. Be converted. The following example shows how to use a cast to compute the fractional part. Right, exactly. Okay. Cool, you can do casts like that. Nice, let me have an example here. Cast int f, it represents the converting the flow. The float type int use it also enables to overrule the compiler force it to do conversions that we want. As it's now written, the result is an integer. We do float dividend divided by the divisor. It'll automatically be converted on the float in the int conversion, making quote. Overflow may occur because you have ints first going into a long. Okay, cool. That's fine for the notes. We don't really need a lot of detail. I was going to see some examples. Okay, type definitions. So a type definition create macros that could be used Notice that the name, capitalizing the first letter of the type name isn't required, just a convenience. Using type def to define bool, causes the compiler to first list. So defining your own custom types using defining custom named types using the build. Right, whatever. So advantages here, you can do like naming, make it really simple and easy to follow. And you just have to change one line rather than a bunch. So type def will be better for portability. You just have to change the one rather than going through and finding all of them. C, library uses type def to create names for types that can vary from one implementation to another. These types have a name that ends with underscore T. So special underscore T types. These are these guys. Pointer diff underscore T, size T, and we har T. We char. C99, the standard in.h header uses type to define names for integer types. So we'll do C99 uses the standard in.int .h header file. Uses C99 standard and for integers types with cool. Nice. Last section. Whoo hoo hoo. What do you mean by episode, Eclipse? I don't know what she meant by that. Oh, like 30-ish episodes of C. Oh, got you. Like a tutorial thing. Okay, the size of operator. The size of operator allows the program to determine how much memory is required. So the size of operator allows you to get for type. Type, we'll take almost there. We'll at the end of the chapter. I thought we were going to get to the exercises today, but oh my gosh, no way, you guys. Sorry. Jeez. Is an unsigned integer representing the number of bytes required to store a value belonging to the type name? The value of the expression is an unsigned type name. Size of char is always 1, but it may vary. Note that size of is rather unusual operator since the compiler itself using that expression. Okay, the value of the expression size of type name is an unsigned integer, the value belonging to the type name size of char is always 1. It's so cold in my room right now. On a 32-bit machine, size of int is normally 4. Okay, cool. Nice. So this gives you size of I, which is an int, which is 4, right? Which is the number of bytes, which is 32 bits, right? 8 times 4. But then if we do size of I plus j, and I and j are both ints, right? This is going to give you back an integer saved, right? It's not going to give you back the size of I plus the size of j. It's giving you back the resulting value of I plus j, which is still an integer, right? I wonder what happens. What happens if you take a size of an integer as it overflows for a signed int, right? Because unsigned doesn't have that. Or is it the other way around? Signed int causes undefined behavior. Unsigned int is defined. Other way around. Okay. Printing the size requires care because the size of expression is implemented is defined in type name size underscore t. In C89, it's best to convert the value of an expression to a known type before printing it. Size underscore t is guaranteed to be an unsigned integer type. So it's safest to cast the size of expression to a positive long integer, the largest of C89's unsigned integer types, and then print it using the LU conversion. In C99, the size underscore t type can be larger than unsigned long. However, the printf function in C99 is capable of displaying size underscore t values directly without the need of casting. The trick is to use the letter Z in the conversion specification, followed by the usual integer code, typically U. Printing size of requires care because the size of expression is implemented defined type named size underscore t. In C89, it's best to convert the value of the expression to a known type before printing it. Size underscore t is guaranteed to be an unsigned integer type, so it's safest to cast a size of expression to unsigned long. Okay, so this is its own type, which is represented in that special cases that we talked about for underscore t types. And we would need to cast it in C89, but with C99, it can do that for us. So I'll say in C89, cast the size of result to unsigned long before printing with the percent LU conversion. In C99, no cast is needed. Just print with the Z prefix to the typical percent U integer code. Codes. So I'll take this for C89. I'll take this for C99. And that is the end of the chapter. Oh my god. Thank you. Oh. Finally. I'm glad to be done with this one. We're going to need a lot of practice for show. For sure. We need a lot of practice with this one. But I'll just go here really quickly and do chapter 7. Exercises. Just so we don't have that annoying directory formatting thing. Cool. It was a series of a video. This guy was making a game made from scratch in C. Yeah, maybe I'll have to give that a listen or watch or something. Some sort of like live C programming just to like jump right in and just get some exposure and try to go line by line and figure out what people were writing. That's honestly what I did for a lot of my Python stuff too, is I would like, you know, if I didn't know the answers to the solutions, I would get the solution and then go literally just like print it out or go and go like line by line and make notes of what was happening in each function, in each line, and like and whatnot, and really just like interpret or translate the code into English, basically. I use %ZU a lot when printing the size of containers. Okay, we'll have to keep that in mind. That'll be an important one. Glad we took a note then. I was thinking about skipping it. Okay. Cool. Thank you guys so much for being here. If you guys aren't subscribed, if you guys could subscribe, we got 13 people here. Thanks so much for joining me. I know it's not an easy thing to take your evenings to sit down and learn and listen to programming, but I think that the people here that are joining us for these types of streams will honestly be the people that are set apart in the future, especially with the way that recent college graduates have been testing, especially with the way that recent high school graduates have been needing like remedial math classes, additional help. I think that the bottleneck with education is going to really ramp up, and if we're putting in the work now, we might not directly be applying whatever we're learning, right? But just by having the stimuli, and doing these types of, exercises in general, it's just like working out, right? It's just like going to the gym, but for your mind, putting yourself through these. There's a guy on YouTube called like the Math Sorcerer, and he just does a lot of like motivational videos and suggestions for learning math and sometimes some programming stuff. And um, it's just very true. Like it's just like really building these kind of skills in your mind. And a lot of people just float by and scroll on their phone and don't do anything after college and lose their entire education, or don't even apply themselves in any sense. And so it's just keep grinding, guys. And I don't know, there's something in me, in my core, like in my heart, that just like believes that like we're doing the right thing. I don't know, like I might just be full of crap. I might eat a bunch of crow later on, but I really, there's just something in me that believes that like to just kind of tune out the small mass of people that are trying to like doubt you and tell you to quit, for like AI purposes or whatever. um I don't know. there's just something in me that just wants to just ignore that and prove them wrong for some reason. But who knows? Maybe we're fighting an uphill battle here, as we always are probably. But it's kind of fun. I don't know. I just think being like intellectual in any sense is a good thing. Having skills like this is a good thing. Even with like AI, like the large majority of people like don't even know how to like do basic math. So, what's gonna make them be able to understand a lot of things, even if the AI gave them basic math, let alone coding and stuff. So I think it's gonna be like a long transition, slow burn. Also, I think you might see some negative effects with people like rejecting due to like politics or involvement in money and whatnot, and then obviously people will probably have to be adapt and succumb to it and eventually, but you might see some initial backlash to regress a little bit, and then before things really, it's gonna be interesting. But cool, thank you guys so much for being here. Sorry about the yap. This was a 2 hour long note session. Jeez, gosh, I thought we were going to be able to get to some of these exercises. We got 15 of them here to grind through. Hopefully we'll get through them all tomorrow. They're just uh, multiple choice questions, almost half of them. So hopefully we won't take too long on them. Um, but yeah, we'll come back tomorrow for some more practice implementing basic types in C with shorts, longs, signed versus unsigned, integer types, integral types versus floating types. We have signed versus unsigned types. I talked about that. We talked about different machines and their types that they might have for various implementations. We talked about casting. We talked about size of. We talked about tons of stuff in here. So if you guys, I'm going to push up my notes here. So let's go ahead and do this. Add finish chapter 7 notes. All right, cool. They're live on my GitHub, so you guys can go ahead and pull the most recent notes from your fork, and I highly suggest you give a read through of the chapter notes we've given so far. And thank you guys so much for being here. I'll see you guys tomorrow. Thanks so much again for 4K subs. We're already over 4023, so 4,023 subs. My goal for the 2025, if I'm going to be honest with you guys, was I had a personal goal of hitting 5,000, but I kind of have backtracked a little bit on that goal, not because of your guys' support at all. You guys have been really supporting me and subscribing a lot. I've been growing like crazy for like the kind of more niche topic that we're doing here, which is really interesting. We're not like doing comedy videos or doing gaming videos really. We have a couple of times, but we're doing programming reading out of textbooks, and we've been able to accumulate 4,000 people that want to watch us read out of textbooks and programs. So it's like a niche kind of audience, and so I don't expect it to be very like popular or lucrative. It's mainly just for the additional study resources for you guys and for myself. That's the main goal of it, right? Um, but my goal was 5,000 by the end of 2025. But I did start, taking days off. I stopped streaming every single day. I started doing maybe like 5 or 6 days a week, just to help with my sanity and my health, and just breaking it up. I just needed a little bit of break in some every now and then, just to recharge my batteries, especially having a full-time job and taking care of my animals and having a girlfriend and doing programming and whatnot. So thanks so much for being here, guys. See you guys tomorrow.